Okay, grade 5, this is a science topic from grade 3. So this is review for you. Maybe you learned it. If you didn't learn it, please pay extra attention because this is the first time you may be hearing this. So this is sound energy. So we explored in grade 3 sound energy at different stations we explored. So first, I want you to feel your neck. What is the difference between not talking, a whisper, and talking? So if you say, my name is Mr. Jeremy, and then you say, my name is Mr. Jeremy, and then you don't say anything, what is the difference? What do you feel in your neck? So some of the observations that grade 3 mentioned were that they could feel their neck shaking more when they talked, and when they whispered their name, they could feel their neck shaking a little bit but not as much, and then when they didn't talk, they couldn't feel their neck shaking. They said they could feel their pulse, like their heartbeat, but they couldn't feel their neck shaking. So, like I said, in grade 3, we tested sound at different stations. One of the stations was a guitar, so the students looked at the guitar and they played with the guitar, and the question, how is sound made, what do you observe, is what they were trying to answer. So they said, I think you make sound by. So some of them said they had to pull the string, and when they saw the string move back and forth, the guitar made sound. So we learned that back and forth movement is called vibration, and the action is vibrate. So the strings on a guitar vibrate to make sound. What is vibration? Vibration is a very small movement, that's motion, backwards and forwards. So you see a picture of the string, it's a little bit blurry, the string from the guitar, that's because it's moving back and forth. We also see vibration in water. If we drop something in, for example, water, we see these circles. Okay, those are caused by vibration in the water, a back and forth movement. So we learned at station 1 the definition of vibration, and that sound is caused by vibration. So that's a passive voice sentence. Vibration causes sound. What is vibration? We learned it's a very small movement backwards and forwards. Station 2, we put rice on a speaker and then we played music. So we told the students to make observations. So what happens to the rice when you make the music louder? Okay, so they wrote as a volume, as the music gets louder, the blank happens. Okay, as the music gets softer, blank happens. So what did they notice and what did we learn from this station? We learned that as the volume gets louder from the speaker, we played music on the speaker, the vibration gets faster. So we noticed that the rice was shaking a lot faster when we played the music louder. And when the volume was quieter, when we played the music softer, the vibration of the rice got slower. So the rice was not shaking as much when we lowered the volume. As the volume gets quieter, the vibration gets slower or lower. So we learned volume is how loud or soft a sound is. So these red bars here are showing you less volume all the way to more volume. So low vibration, when something has less volume, the vibration's lower. When it has more volume, vibration is faster. So if you want more volume, you have to make something vibrate faster. So remember when I told you to feel your neck, the louder you speak, the more vibration you feel in your neck. The quieter you speak, the less vibration you feel in your neck. So again, the teaching points from this station were as the volume increases, the rice vibrates more. The higher or more the volume, the higher the vibration. The lower or less volume, the lower the vibration. That's true about the rice, and that's true when you talk, when you can feel it in your neck. So we also did station 3, water bottle xylophone. So the kids blew into each bottle and then they listened for a sound. This is just the procedure. You can try to do this at home if you have beer bottles. You can fill them to different levels. So one bottle could be high, one bottle could be medium, and one bottle could have a small amount of water. So what did we notice? What did we notice when we blew into each of these bottles? So if you notice, bottle 1 has no water, just air. Bottle 2 has some water and a lot of air, and bottle 3 has more water and less air. So we learned, our observations were the larger, the more air in a bottle, the lower the pitch. The smaller amount of air, less air in the bottle, was a higher pitch. So bottle 3 of these 3 bottles has a higher pitch because it has less air. Bottle number 1 has a lower pitch because it has more air. And this is just an extra question. How do you make a higher pitch when you blow into a flute? We learned that pitch means how high or low a sound is. So two different sounds can have the same volume, the same level of volume, but a different pitch. And so a higher pitch is created by a faster vibration, and like a whistle. So if you hear your coach during PE class blow the whistle, that's more like a higher pitch. And if you hear a drum, that's a slower vibration, that's a lower pitch. We learned about how sound travels through liquids, solids, and gases. So we tapped, we made the same sound. We hit our desk, we knocked on our desk, tapped 3 times, and first we just listened through the air. So we tapped on the desk and listened through the air. Then we listened through a book, which is a solid. Then we listened through a liquid. We put the students put a water balloon against their ear and they made the same sound, okay? And they were just writing observations about how, if the sound was different, like if there was one that was loud or louder. And this made us ask the question, does sound travel faster through solids, liquids, or gases? So look at the diagrams, the particles you learned in grade 3 that states of matter, solids, liquids, and gases are made of particles, and that solids have a definite shape and volume, so the particles tend to be closer. Liquids take the shape of their container. They don't have a definite shape, so the particles tend to be spread out more. And then gases also do not have a definite shape or a definite volume. They do not. So that's why the particles are spread out even more. Okay, so back to sound. When sound's traveling through the air or through water or through just solid, does it travel faster through liquids, solids, or gases? What do you think? Look at the diagram of the particles for your answer. Do you say A, B, or C? So, sound travels, this is what we need to know, through liquids, solids, and gases like air. Sound is a vibration and has to travel through matter. It has to travel through matter. It cannot travel through empty space. Sound travels faster through solids because the particles in solids are closer together. So answer choice A was the answer. Sound travels slowest through gases because the particles in gases are farther apart. Okay, so at station 5, we did as a class, we measured sounds using an apparatus. Do you know what apparatus we use to measure sound? Okay, so we made different sounds. We know sound is made by vibration, so we clapped our hands. The students made predictions in a unit called decibels. We measure sound in decibels, just like we measure length in centimeters, right? Just like we measure force and weight in newtons, just like we measure mass in grams, we measure sound in a unit called decibels. Okay, so each time we measured about 50 decibels for clap your hands. For slam the door, we measured about 75 for each time, and then for whisper your name, we measured about 20 each time. So the lower the number, the lower or quieter the sound. The higher the number, the higher or louder the volume of the sound. And then we put our results on a bar graph table like the one you see here. You can see whisper your name, 20 decibels. So what would you call this bar graph? What would you label the numbers? What are we counting? Okay. So we learned that we measure sound with decibels using an apparatus called a sound meter. These are some of our conclusions that I've already read. So when you study, you can fill in the gaps here. So sound travels faster through which state of matter and why? Sound travels slowest through which state of matter and why? Here are the answers. So we did a singing glass. You can try this at home. If you have a wine glass, you can put some water in it and then wet the tip of your finger and rub the rim of the glass with your finger and try to create a vibration and see what you hear. So as mentioned, decibels and sound meter. And then here are some other sounds and their volume in decibels. So we have a trombone, which is 114 decibels. dB stands for decibels, all the way down to a washing machine, which is 60, they say 60 decibels. So like I said, volume, the higher the number on the decibel scale, the louder the volume. So where would you put each of these? Normal conversation. What about your headphones when you are listening to music at max volume? Where would you put that? Would you put that at 100? An airplane, a rock band, and a car. So here are some of the answers. Like normal conversation is 60, the whisper is 20, Rock Band is 110 decibels, just to give you an idea of what those numbers mean. So is there another way you can change the sound of the guitar on a string? So notice in the picture on the right, the guy is pressing the strings higher, and here he's pressing the strings lower. So let's assume he's pressing the same or pulling the same string to make a sound. Will the sound be higher pitch or lower pitch on the left? What about on the right? Higher or lower? So as a string on a guitar gets thicker, the pitch gets lower. So if you play guitar, you know some strings are thicker and some are thinner. So the thicker strings, the pitch is lower. The thinner strings, the pitch gets higher. And if you press down on the strings and you keep going down that part of the guitar called fretboard, the pitch gets higher the more you go down. So the higher you go, the pitch gets higher. I have to redo that one. So again, this is reminding us what makes a fair test. How do we make a test fair in science? And we compared it to a fair race. How do we make a race fair? We know what a factor is and what a variable is. There should be one variable in an investigation. So let's plan a fair investigation. So let's say our question is, which material muffles or blocks the sound the best? What should we use in our investigation? These are examples of muffling sound. What do you think muffle means? So what do you see? I see people wearing headphones to block sound outside. Or in the case of the woman sleeping, maybe she's trying to block out somebody snoring at night. So what do we mean by muffle? Muffle means to make sounds less and less clear, to insulate or block sound. So we want to plan a fair investigation about which material muffles sound better, which factors would be the same, and which one would be different. So some of the same factors would be a source of sound, like a cell phone. So we could play music from a cell phone. Number two, same sound, like a song. So we would play the same song every time. Number three, the same volume. So we wouldn't change the volume when we use a different material. We would have the same amount of material. And five, the same container of sound, like a shoebox. So we could put the cell phone inside a shoebox and then cover it with a different material, okay? And so what would be the variable? Like I said, it would be the different type of material to block the sound. That would be the variable. You would use the same amount of material, but the material itself would be different. And then we could predict which material. Maybe we have foil or bubble wrap or a towel, for example. This is just a procedure telling you how to conduct the investigation, first, second, next, and so on. So what should we use to measure our results? Should we use a tape measure or a scale or a sound meter? And then we could record our results. We like to test things more than one time to see if we're doing it the same every time. And then we could plot our results on a graph, bar graph. So you could think about what could be the title of the bar graph, what could we label the numbers, and what should we label the bars. Here are some very important words you need to know if you want to write a conclusion about sound, muffling sound. And then here are some videos you can watch to hear the difference between a higher pitch and a lower pitch. Same thing here. And these are just extra sounds that you could search on YouTube and determine if they have a high pitch or low pitch, high volume or low volume. And I hope that helped.